All right, so let's dive into this research on prompt engineering. It's been getting a lot of attention lately, and for good reason. I mean, we're using these large language models more and more these days, ChatGPT obviously being the big one. But it really makes you wonder, are we using them right? Like, are we really getting everything we can out of them?
Well, the paper you sent me suggests maybe not. It really digs into this whole idea of prompt formatting, which is basically not just what we're asking these models, but the way we structure the information.
So, like, are we talking like plain text versus code, or like using specific markup language kind of thing?
Exactly. So they tested these different GPT models, like versions 3.5 and 4, across a whole range of tasks. And they used all these different formats like plain text Markdown, even YAML and JSON. And what they found is pretty crazy formatting has a huge impact on the results.
Wait, so you're saying just changing how the information looks, even if the actual content's the same, can seriously mess with the output?
Yeah, it can make a massive difference. I was this one example where they had GPT 3.5 Turbo doing code translation, and just by switching up the format, they saw a 40% swing in performance.
Whoa, 40%. That's wild. What could even cause that big of a change?
Honestly, it's not totally clear yet, but it definitely throws a wrench in a lot of our assumptions. And, we tend to think these models can just grab the meaning no matter how it's presented. But this is showing us that the format itself carries a lot of weight in how they process things.
Huh. So is there like a best format then? Like a way to structure prompts that guarantees you're going to get the best possible results?
Well, that's the million-dollar question, isn't it? And the answer is unfortunately no. There's no one-size-fits-all winner. Something that works for one model might not work for another, even for different versions of the same model.
So each model, each version, they've all got their own little quirks, their own preferences for how they like their information packaged up.
Exactly. For example, they found that GPT 3.5 models tend to prefer JSON, while GPT-4 leans more towards Markdown. So even within the same family, there's no real consistency.
Man, this makes prompt engineering a lot more complicated than I thought. It's like you need to learn a whole new language for each model.
That's a really good analogy, and it brings up another big question. Are we even evaluating these LLMs properly? If something as basic as formatting can totally change the game, how can we really compare different models accurately?
That's a great point. Most of these benchmarks, they use these fixed prompt templates. So if those templates aren't optimized for each model, are we really getting a true picture of what they can do? I mean, we could be totally underestimating some models and overestimating others.
Exactly. This research is like a wake up call. We can't just keep throwing data at these models or hoping for the best. We need to dig deeper into how they actually process information, how they think, if we want to unlock their full potential.
It's like we're trying to crack the code of AI.
Exactly. It's about understanding not just what they know, but how they know it. And this whole thing about consistency actually connects to another really important aspect of prompt engineering, and that's transferability.
Transferability. So like if you figure out what works for one model, can you just apply that to another one?
Right. Like, is there some magic formula that works across the board? Well, the researchers use this metric called intersection over union, or IOU, to see how much overlap there was between the top performing formats for different models.
And I'm guessing the results weren't too promising?
Yeah, not really. The IOU scores were pretty low, especially when you compare GPT 3.5 and GT4 models. Basically, what that tells us is that even if you find the perfect format for one model, it's probably not going to work the same way for another one, even within the same family.
So each model is like its own unique puzzle, and you got to figure out the right approach for each one. There's no easy shortcuts.
Exactly. It really highlights the need for model specific prompt engineering. We can't just rely on generic solutions. We got to get to know each model individually and figure out what makes it tick.
Man, this is a lot to take in. I'm starting to realize that prompt engineering is way deeper than I initially thought.
Yeah, it's not just about coming up with clever prompts. It's about understanding how these models work on a fundamental level, how they perceive information, how they process it. It's like learning how to communicate with a whole new kind of intelligence.
It's almost like we're learning the language of AI.
That's a perfect way to put it. And just like with any language, it takes time and praxis and a willingness to experiment to become fluent.
So if there's no one-size-fits-all solution, and you can't just copy and paste what works from one model to another, how do we even approach prompt engineering in a systematic way? Where do we even begin?
Well, I think the first step is to shift our mindset. We need to move away from this idea of finding the perfect prompt because that might not even exist. And instead, we need to embrace a more dynamic and iterative approach.
So instead of looking for that magic bullet, we should be testing things out, experimenting with different formats, and seeing what works best for each model and each task.
Exactly. It's all about discovery, a constant back and forth between us and the model, where we learn and adapt based on the feedback we're getting.
This research is also making me think about how we evaluate these models. If their performance can change so much, depending on the format of the prompt, are the ways we're currently measuring them even accurate?
That's a really good question. A lot of the benchmarks out there use these fixed prompt templates, which we now know might not be ideal for all models. So, yeah, it's definitely possible that we're getting skewed results. Maybe we're underestimating the capabilities of some models and overestimating others.
So it sounds like we need a more sophisticated way to evaluate these models, one that takes into account how sensitive they are to formatting.
Absolutely. We need to move beyond these simple benchmarks and develop more nuanced evaluation methods that can capture the complex interplay.
Hey there. Want to share your thoughts on this?
Hey there, what's the key takeaway?
Oh, yeah. Let's hear it.
Hey, what's the key takeaway of this paper?
Oh, hey, thanks for chiming in.
Yeah, great to hear from you.
Okay, so the key takeaway, if you want the really short version, is that how you format your prompts for large language models really matters.
Like, really matters. The research showed that just by changing the format, say from plain text to JSON, you can see huge swings in how a model performs.
Yeah, we're talking up to 40% difference in some cases. It's not just about the words you use, but also how those words are structured.
Exactly. And this also means that a best prompt format for one model doesn't mean it'll be best for another model.
So it's definitely not a one-size-fits-all kind of thing, which kind of throws a wrench in how we think about prompt engineering and even how we test these models.
That's right. It also highlights the need to move beyond fixed prompt templates and instead try testing with a variety of formats. We had just gotten to the need for a more nuanced approach to evaluation.
Okay, so with that in mind, let's pick up where we left off. We were talking about how current evaluation methods might be a little flawed.
Right, because if a model's performance is heavily influenced by prompt format, using only fixed templates may not provide a complete picture of its capabilities.
So we need a better way to test these models, something that takes into account this format sensitivity.
Precisely. The study suggests that future LLM evaluations should incorporate a diverse range of prompt formats.
Yeah, it's like we can't just assume that if a model does well with one format, it'll do equally well with another.
And it's not just about testing, it also means we need to approach prompt engineering differently.
You're saying instead of searching for one perfect prompt, we should be experimenting with multiple formats to see what works best, right?
Exactly. This means taking the time to really understand each model's nuances, almost like they have individual preferences.
It's like they each have their own language and we have to learn to speak it.
Precisely. And that also gets to a whole other element the paper touches on, and that's the idea of consistency.
Ah, yes, consistency, which is not always something we can count on.
Right. Consistency is all about whether or not a model provides the same output to the same input when using different prompt templates. So, like, is it reliable and predictable?
And as we might guess, they found smaller models, like the GPT 3.5 series, to be less consistent across different formats.
Exactly. While the larger models in the GPT-4 series showed significantly higher consistency. So that is a big takeaway as well.
So even if the model gives you a good result, it might not always do it, which is definitely not ideal.
Which underscores the need for more rigorous testing and model-specific approaches when it comes to prompt engineering.
Yeah,